Hi, welcome to another episode of Paultre on Power System Design's podcast on the latest in power and power design. I'm your host, Alix Paultre, and today I'm very lucky to have Daniel Cooley from Silicon Labs with me. He's VP of their IoT products, and, well, as you know, Internet of Things has become a huge area. Isn't that right, Daniel? Welcome to the show.
Thanks for having me.
Well, it is. It's well, obviously, power's sexy again. You know, you got to do the little dance. Because it's more about power awareness. It's not really about how big the battery is. It's how long will the battery last. And it's all critical into the systems now. They have to be efficient. They have to be high quality. They have to provide the functionality. So what are you doing with the Gecko series to address those things?
It's a great question, and you're exactly right. In fact, most of my customers today have issues of battery life management over multiple years. This is a real challenge because they haven't seen this before, and they're writing more software than they ever have. So we're launching a new portfolio of wireless products, our wireless Geckos, and that are really targeted at energy efficiency in low-power wireless communications. This isn't Wi-Fi. This is more command and control-based wireless communication. So Thread, Zigbee, Bluetooth Smart, and proprietary wireless.
So all low-power, near-field, close-range communications.
Yes. So what we do is we provide a lot of course, it's a chip family that has a lot of scalable microcontroller features and wireless features, high-efficiency PAs being one of them. But in addition to that, we provide a lot of tools to aid in energy debugging of an application. And so for a lot of software developers, they don't necessarily understand how their code translates to coulombs coming out of a battery. And so, that connection's not exactly obvious because they're used to optimizing for code space, efficiency, timing, repeatability. They want to make sure they can compile their code across multiple compilers with the same results. I mean, there's a lot of degrees of freedom, and then you throw on, okay, this thing has to live for 3, 5, 7, 10 years.
Or longer.
Well, we have customers doing 20 years, and they put these meters in the ground. They have to manage the battery very carefully. So we provide a tool in our Simplicity Studio tool suite called Energy Profiler. And what Energy Profiler allows you to do is you see your code, your actual code running in an application with the power consumption real time, and we align the program counter to the DAC samples in the power supply so you can see exactly which line of code is triggering power events. So you'll see big spikes of current power consumption coming into your application, and then you could trace it back to a line of code that did it. So you provide gamification so the software developers can see their power consumption, and that's what they can start optimizing their code to.
Got it.
And so our customers use this in applications that have to be multiple years in consumer or security, like in connected home, 20-year battery life, 10 to 20-year battery life applications in smart metering, and everything in between.
Because now there's a lot with the Internet of Things in field sensing, a lot of remote sensors out there now, a lot of remote devices that, I mean, frankly, there are engineers thinking up remote devices and applications and functions that we haven't even thought of yet.
Yep. Actually, every time I sit down and talk with a customer, it's a new application coming up. So fortunately, we have the core tools. We can help through the certification of these devices, not just FCC and ETSI, but also certification into people's end ecosystems. Okay, so think about things like HomeKit. We can help people get through those certification bodies.
Got it. And I see this cute little race car thingy here. What does that mean?
So this is a new platform that's being demonstrated today. It'll be launching later this year in April. It's called our Thunderboard React platform. And so it's got a little CR2032 coin cell battery powering a Bluetooth module that has our wireless Gecko inside. It's got a lot of sensors on it. It's got magnetic, temperature, humidity. It's got ambient light. And I'm going to demonstrate we put this on a Pinewood Derby car chassis, and so kids can optimize their Pinewood Derby designs using it. So we give them an app, and I'm going to show that app very, very quickly. And so this app, if you can zoom in on that, shows the car moving, rotating in real time. So I can stop it, I can rotate it. It's kind of a cool little app. You can roll the car, and you can see the acceleration, the speed, and people, kids can tune their design. So it's kind of like gamification, IoTing of something like a Pinewood Derby car.
Boy Scouts will be after you for that.
Oh yeah, everybody we've shown it to says, "I wish I would have had that when I was in Boy Scouts."
Although I don't, got to check the rules about electronics in the car.
Well, they can take it out in their final design, but during the phase of engineering the design, making it better and better and better, they can have results, and they can say, "Well, last week's is a little bit slower than this week, so I made a change, and now it's slightly slower." Things you can't necessarily measure. You want to know the acceleration all the way through, not just how long it took.
And obviously, Soapbox is just a microcosm of the possibilities, because that Soapbox Derby car could easily be a full-size car or an aircraft or a...
Anything that's battery powered. I mean, that's the thing. This thing doesn't have to be tied up to anything. And so it's Bluetooth connected. It's really fun to use, and we're going to have a lot more things like that.
Very cool.
And one more thing.
I was just going to ask you about, what's this with the lights behind us?
Yes, so this light show is being put on by a new wireless technology called Thread. So Thread is a low-power mesh networking-based technology that it brings IP addressability into an open standard. So those bulbs right there are all being powered or controlled by an app on our iPad here, sending out commands to a gateway that is then relaying them back to the light bulbs real time.
Very cool.
It's ultra low power. It is, and you don't think about lighting being ultra low power, but the lighting control side has to be really low power. You need 7 years of battery life on a switch. Okay, so that's the real challenge here. So you bring IP addressability to mesh networking, and that's the combination. It's called Thread.
Very nice. Well, hey, Daniel, thank you so much for being on the show today. We really appreciate all this cool information.
Thanks for having me. It was fun.
Oh, and what's the website they should go look at?
Scilabs.com/wirelessgecko.
Excellent. Thanks again, Daniel. And I'd like to thank everybody out there in the audience for taking the time to be with us. We wouldn't be here without you. Tell your friends. This is Alix Paultre for Paultre on Power. Have a great day.